Last question. A point P is outside the circle. Okay, go ahead.
It is 15 centimeters.
Unfortunately, no. I continue. Outside the circle of radius 10 centimeters, and the tangent from P to the circle is 24 centimeters long. Find the shortest distance from the point P to the circle. Yes.
The point P is outside a circle of radius 10 centimeters, and the tangent from the point P to the circle is 24 centimeters. Find the shortest distance from P to the circle. Now, in the NSMQ, you have few seconds to do this. If you are still drawing circles and writing equations, then by the time you finish, the time will already be up. In this video, I'll be showing you an NSMQ shortcut to answer this question before the quiz mistress even finishes reading the sentence. Let's look at the normal way of solving this. So we've been given a circle, and then the point P outside the circle. The circle has a radius of 10 centimeters, and a tangent joins the point P and the circle. The tangent is 24 centimeters long. Straightforward, if you remember our golden rule of circle geometry, we know that a tangent is perpendicular to the radius of a circle at the point of contact. It means the 24 centimeters tangent and the radius 10 centimeters are perpendicular, meaning the angle between them is 90 degrees. If so, then a line joining the center of the circle to the point P will become the hypotenuse of a triangle formed by the three lines. Now, the mistake most students do at this point is that they find the hypotenuse of the triangle and then ring the bell and deliver that as the answer, or then they provide that as their answer. You are close to the answer, alright, but that is not correct. What you are supposed to do is to find the shortest distance from the point P to the circle, not to the center of the circle. Okay, so the shortest distance from P to the circle is the small segment from P to the circumference of the circle. And that is what we're actually looking for. So ordinarily, students will use the Pythagorean theorem and find the hypotenuse of the triangle and subtract the radius from the hypotenuse to give us the shortest distance between the point P and the circle. Let's look at how they do that. So Pythagorean theorem is a squared plus b squared equals c squared. So we square 10, that gives us 100, then we square 24. 24 squared is 24 times 24. We do that long computation and get 576. We add those two numbers together, that gives us 676. Then we'll now find the square root of 676. This is not something we can do easily, but then we do this anyways, and then we get 26. After getting 26, which is the hypotenuse of the triangle, we subtract the radius 10 centimeters from it, and that becomes 16 centimeters. And then that's the answer. This is a very, very, very long process. Is the answer correct? Yes, the answer is very much correct. Is it short? No. Is it fast? Absolutely not. So, this is when the NSMQ shortcut comes in. You can finish this if you are fast before she even finishes the sentence. And we've been given the radius 10 centimeters and a tangent 24 centimeters. We have to find the hypotenuse and subtract the radius from the hypotenuse. But we should remember something from Pythagorean triples. Now, if you don't know Pythagorean triples, then they are three numbers that form the rule a squared plus b squared equals c squared. So we can have 1, 1, and 2, meaning that 1 squared plus 1 squared equals square root of 2 squared. So those 1, 1, and 2 are Pythagorean triples. We also have 3, 4, 5, meaning that 3 squared plus 4 squared equals 5 squared. So 3, 4, and 5 are Pythagorean triples. Another one is 5, 12, 13. 5 squared plus 12 squared equals 13 squared. We even have 6, 8, 10. 6 squared plus 8 squared is equal to 10 squared. So those are Pythagorean triples. Now, constant multiples of Pythagorean triples are also Pythagorean triples. What does that mean? It means that if I multiply the three numbers that form the Pythagorean triples by a constant number, the result is a Pythagorean triple. So for example, 1, 1 is 2. If I multiply all that by 2, the result is also a Pythagorean triple. So 2, 2, 2 with 2 forms another Pythagorean triple. The same way, 6, 8, 10 is a Pythagorean triple. You can see, I mentioned it earlier, 6, 8, 10. Pythagorean triples are formed when you multiply other Pythagorean triples by constant numbers, by 5, 10, 50, 20. It doesn't matter the number you multiply it by. So first you multiply all the three numbers by that same number. Then the resultant is also a Pythagorean triple. It means if I divide a Pythagorean triple by a constant number, the result is also a Pythagorean triple. How does that help us in our NSMQ shortcuts? We've been given 10 and 24. We have to find the next number in a Pythagorean triple that will become the hypotenuse of the triangle. Instead of squaring 10 and squaring 24 and finding the square to give us the next number, what we do is that we divide by a constant number until we cannot divide anymore. So I divide 10 and 24 by a constant number. What number can go into 10 and 24? Yes, 2. So I divide 10 and 24 by 2. So dividing 10 by 2, I get 5. Dividing 24 by 2, I get 12. 5, 12, and another number for Pythagorean triple. We know that already. We should know some of these basic Pythagorean triples offhand. So we know that 5, 12, 13 is a Pythagorean triple. Now, since I divided by 2, I can multiply it by 2 again to get the original Pythagorean triple. So if I multiply 5, 12, 13 by 2, I get 10, 24, 26. So to be fast, I don't have to multiply the whole thing by 2. I can just multiply the hypotenuse by a constant term to get back the original hypotenuse, which would be 26. After getting the 26, I just subtract my radius 10 centimeters from it to get 16 centimeters as my answer. So let's take the question again to see how the trick actually works and how fast it actually is. So a point P is outside a circle of radius 10 centimeters. A tangent from P to the circle is 24 centimeters long. Find the shortest distance between the points P and the circle. So when you're just giving the point and the numbers 10 and 24, you know you're finding the hypotenuse and subtracting radius. So 10, 24 divided by 2, you get 5, 12, 13. Multiply 13 by 2, 26 minus radius. Then you get 16 centimeters. Then you just press the ball. So you can do all of this even in your head without writing anything on paper. Before she even finishes, you find the shortest distance. Let's take another question and see how we do this one too. A point P lies outside the circle of radius 6 centimeters. A tangent line joins the point P and the circle. The tangent has a radius of 8 centimeters. Find the shortest distance between the point P and the circle. You can see 6, 8 divided by what? Divide by 2. You get 3, 4. 3, 4, 5. It's a Pythagorean triple, so 5 times 2. 10. That's the hypotenuse, right? Then you subtract the radius. The radius is what? 6 centimeters. So 10 minus 6. That gives you 4 centimeters. And that's the final answer. So I've provided you with a list of Pythagorean triples, the base ones that you need to memorize. Not all, but maybe a few. Getting higher in the chain is going to be very hard to memorize them, and I don't think questions will come from that side. So the base ones, the basic ones, yeah. Let's take a final question. A point P lies outside a circle of radius 24 centimeters. A tangent line of length 45 centimeters joins the point P to a circle. Find the shortest distance between the point P and the circle. Alright, so you can drop the answer in the comment section. If you enjoyed this video, give us a like, subscribe to this channel for more NSMQ content. See you in the next video.